Side, side, side states the following. If three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. So we're looking for congruent sides. What markings do we use to show congruent sides? The little tick mark. So maybe I would have this side congruent to this side. And then maybe I would have this side congruent to this side. And then maybe I would have the third sides congruent to each other. If I have all three corresponding sides being shown congruent, then I could say, yes, these triangles are congruent because of side, side, side. Okay? So the first side of your homework is similar to these next three problems. You're asked, can you determine whether the following triangles are congruent due to side, side, side? Do you have three sets of congruent sides? Yes. So I would say yes.
I feel like this postulate is so obvious.
It is very obvious.
Like all the other ones you have to kind of think about, but this one is like, I wouldn't even expect there to be a postulate.
Right. I know. That's why it's a postulate. If so, write a congruent statement. So then we would say triangle ABC is congruent to, what would A match up on the other side with? E, good. B would match up with D, and then we're left with F. Okay. Part B. Do we have three congruent matching sides? Yeah. I see AC and DB congruent. The top and the bottom are congruent. Where's the third congruent side? Right down the middle. The good old reflexive property gives us that. So I would say yes. So triangle ACD is congruent to A matches up with D on the other side. C matches up with B, and D matches up with A on the other side. For part C, do I have all three sets of congruent corresponding sides?
Yes.
I do?
No.
No. I have only two sets of congruent corresponding sides. So can we prove congruence through side, side, side?
No.
Not possible. Okay, so that's what your whole numbers 1 through 14 are on your homework. They're pretty easy. So now let's flip on to the next page. So next example is going to be similar to your problem 17, 18, and 19. It's just that it's not graphed for you. I would personally make the graphs myself. But let's do this one together since it's already graphed for us and we're short on time. In order to decide whether these are congruent or not, I need to know that all three sides are the same length. Well, what's nice about this is I have a right triangle, so I can just count units on my horizontal and vertical side lengths. So what is the length of AB in that triangle? Count the units.
AB is 1, 2, 3, 4, 5.
5, good. The length of AC is 3. How do we find the length of BC? We can use that good old distance formula.
Hate that.
See, why would I do that? I don't care about that.
Well, okay, so if you don't like the distance formula, do you guys remember the Pythagorean theorem, even though we technically haven't learned in this class?
Wait, what is that?
A squared plus B squared equals C squared. Do you guys remember doing that?
Oh yeah, that's a little bit better.
So you could do 5 squared plus 3 squared.
5 squared is 25.
So 5 squared plus 3 squared is 25 plus 9,
So it'll be 39.
34. So it'd be the square root of 34.
4.
Now let's go over to the other side.
That's the answer right there?
Yep, the square root of 34. The Pythagorean theorem pretty much is the Pythagorean theorem, or the distance theorem is the Pythagorean theorem. Now let's go to the other side. What is the length of GF? How many units? Is it 5? I think it's 5. 1, 2, 3, 4, 5. HF is 3. If we did the same thing to find HG, HG would be the square root of 5 squared plus 3 squared, so it's the square root of 34. So are they congruent? Yes. Yes, congruent. Because all the sides are the same length. So on your homework, you can just do a whole bunch of distance formulas, or you can graph them and hope that they are perpendicular, which they probably are, and just count units. Okay? We'll skip the next example and go down to the last one, because we're short on time. So the last type of problem you're going to do on your homework assignment is to figure out what missing piece of information is needed. So in order to prove that these triangles are congruent for side, 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 what's the missing set of sides do you need? I have A, yeah. So the missing piece of information I need is that AB is congruent to, so if I'm going AB, then I should go IH. So you just need the third missing side. And that is side, side, side.
Wow.
3 sets of congruent corresponding sides. Because you need, well, it's asking you to state the additional piece of information needed to show that you have side, side, side. So they give you 2 sets of congruent sides already, so the third set would be that. Okay?
That's probably 15.
Yep.
Nice.
All right.